Hey y'all, welcome to the first quiz of second semester. Alright, so here's your need to know info. First of all, similar triangles. Those are triangles whose corresponding angles are equal, and therefore their corresponding side lengths are proportional. So we're going to be setting up a lot of proportions. Something over something equals something over something. Alright, some other things that we need to know to be successful in this quiz. There's 3 ways to prove triangles are similar. You can use angle-angle, you can use side-side-side, or side-angle-side. Now remember, there's a big difference between side-side-side in congruent triangles and side-side-side in similar triangles. In congruent triangles, we were showing that the corresponding sides were the exact same length, and in similar triangles, we're trying to show that the corresponding sides are proportional. So there is a difference there. And then you also need to know the side splitter theorem, which is just basically top over bottom equals top over bottom. So let's do some problems. All right. Triangle FSB is similar to ZDR. Now this similarity statement is important because it tells us the corresponding side lengths. So for example, if I want to use side length FS, I'm going to go back and check to make sure that it corresponds, or I'm going to go back and see what it corresponds to. This picture is nice because it lines it up perfectly, but a lot of times it won't. So always go back and check from your similarity statement. All right, so I'm going to go ahead and because they're similar, I'm going to set up the side lengths proportional. So I'm going to set up some proportions. I'm going to go ahead and say 38 over 15.2 has to equal, and I kind of like to label it to give myself a note of what I did. I did the big triangle over the little triangle. So I need to make sure that my second fraction is also the big triangle over the little triangle. I got to make sure I line them up correctly. So the next side length that I know off the big triangle is FB. And then FB is the first and the last. It corresponds to ZR. Okay, so now I have my proportion. Big over little equals big over little. You could have done it little over big. There's lots of different ways you could have done it, but that's just how I chose to. All right, and then from here, to solve a proportion, we cross multiply. So 38 times x is 38x, and 55 times 15.2 is 836. And then to solve the equation, we would divide each side by 38. So x equals 22. Now let's go back over here and make sure that makes sense. I like to check these with scale factor. And you can use scale factor to solve the whole thing if you want to. But it's a good way to check them. So if I want to start with the big triangle and end up at the little triangle, I'm going to ask myself, well, how do I go from 38 to 15.2? And if I divide that, 38 divided by 15.2, that would give me a scale factor of 2.5. So then I could make sure I was using the same scale factor here. So I could take 55 and I could multiply it. I'm sorry, I said that backwards. Divide it by 2.5. And it would equal 22. Let's pretend like that's a division symbol. I always set up the proportions because it's my favorite method, but then you can check it with scale factor if you want to. Okay, the two triangles are similar. What is the value of x? I'm going to go ahead and separate these two triangles, make it a little bit easier for me to see. So I'm going to take the smaller purple triangle. I'm going to label it. And then I'm going to take this bigger red triangle. I'm going to label it as well. Now here's the side that's tricky. This side right here is not just 6 units long. It's 6 plus 8. You got to add both of those pieces together. So this whole side length is 14. That's a spot that a lot of people will make a mistake on, so be really careful about that. But now that we have it, we can go ahead and set up our proportions. And we know we can set up proportions because it says they are similar. And in similar figures, the sides have to be proportional. So I'm going to use the side between the two angle markings first. So I'm going to do little triangle over big. So my first fraction would be 2x minus 2, not over 3x. And then I need to make sure I use the little triangle again first. So little over big. And now we can cross multiply to solve it. So let's do it. 3x times 8 is going to be 24x. And 2x minus 2 times 14. You got to multiply that 14 by both of those pieces. You got to distribute the 14 and make sure you get it to both of them. So that's going to be 28x minus 28. And now to solve this equation, I have x's on both sides. I want to get them on the same side. So I'm going to go ahead and subtract 28x from each side. That'll cancel it out over here. I'm just going to plop that one straight down. And then to finish solving for x, I need to divide each side by -4. And 28 divided by 4 is 7. And let's just make sure we answer the question. The question says, what is the value of x? So x equals 7. All right, here's the next one. What is the value of x? Now this one looks a little different because it doesn't show us, doesn't really look like two separate similar triangles, but they are. But we have this shortcut called the side splitter theorem, which if you remember back on the need to know info, you could basically just take top over bottom of one side and set it equal to top over bottom on the other side. So that's how I'm going to set up my fraction. I'm going to do top over bottom. So 10 over x, that comes from this side, equals 15 over 42, which is from the other side. And then you'd still cross multiply to solve. 15 times x is 15x. And 10 times 42 is 420. Then you could divide each side by 15. And x is going to equal something. 28. Cool. And again, it just says solve, find the value of x, so that would be our final answer. You got to be careful to read the question, though, because sometimes you have to plug it back in to find a side length. So just be careful that you read it. All right. Which triangle is triangle ABC similar to, and why? Wow, I had a hard time reading there for a second. All right, so we're comparing them to triangle ABC. Now notice it gives us two angles. I want to go ahead and find the third angle. I want to know all three angles in triangle ABC. So remember, the sum of the interior angles of a triangle has to add up to 180. So I could take 65 plus 65 and then subtract that from 180. And that tells me that that angle has to be 50 degrees. All right, so now I know all of my angles. For another triangle to be similar to it, it has to have congruent corresponding angles. So the angles that go together have to be equal. All right, so let's just start looking at some of these answer options. I'm just going to look at my pictures first. So this says 65, that corresponds, and this one says 60. Wah, wah, has to be 65. So this one says 65 and 20, that's no good because it has to be 50. This one says 65 and 50, which matches up perfectly. So this is going to be the triangle that's similar to it. And the reason it's similar is because two of the angles are congruent. So triangle ABC is similar to GHI by the angle-angle similarity postulate. All right, and then the last one, is triangle FHK similar to GHI? And if so, which postulate or theorem proves these two triangles are similar? All right, so it helps to kind of split these apart. FHK is this giant triangle. So I'm going to draw that big triangle. And I'm going to go ahead and fill in what I know. So like FH, I know that side length, if I add it together, would be 22 inches. And then from H to K, oops, that's the wrong letter. From H to K, if I add these two together, let's see, we would have 33 inches. All right, so there's my big triangle. I also want to draw my little triangle. All right, so it's GHJ. And it just helps me visually to split them apart. So I've taken this little triangle and I've just plopped it out over here. From GH, I know that that side length is 10 inches. And from H to J, I know that side length is 15 inches. And so now I need to decide if they're similar. Well, one thing that's kind of hidden is that they both share point H. So I know that angle H is congruent to angle H because it's literally the exact same angle. So I know that both of those angles are going to be the same. Then the other information that I'm given is I'm given two side lengths. So if I had to guess here, I'm guessing that I'm going to be using an angle and two side lengths. Okay? But we need to check to make sure the sides are proportional. So I'm going to take and set up a proportion to make sure they're equal. So I'm going to take 22 over 10, the big triangle over the little triangle, and I'm going to see if that equals 33 over 15. Again, the big triangle, oops, over the little triangle. Now from here you can cross multiply or you can reduce each fraction since you know all of the numbers. I'll just go ahead and cross multiply because that's what we're used to doing. So 22 times 15 equals 330. And 33 times 10 also equals 330. So because they're equal, we know they are proportional. So we have an angle and two sides that are proportional. So we know that's similar. It's not because of side, 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 and they're not similar. Just said not twice. So now we need to figure out whether it's SSA or SAS. Now remember, this is the wordy dird. That's the dirty word backwards, and that never works. But the mathematical way of looking at it is the angle is in between the two sides. Notice your two sides and then the angle's in between it. That's called the included angle. So that one is our answer. All right, y'all, good luck on the quiz.